Start recording. Okay. Okay. So now remember, well, you don't know this yet, but that's okay. Smaller metals are more electronegative. So we're just going to ignore that part because it's not relevant just yet. When naming ionic compounds, the metal is always first, and the second one is always "ide." Formula unit is a single unit of an ionic compound. You probably didn't need any of that. Okay, so let's get into the drawing of Lewis structures for these ionic compounds. The first thing we do is we draw the Lewis structure of the atoms, which we reviewed for you yesterday. The second thing we do is we use arrows to show the transfer of electrons from the metal to the nonmetal. And finally, we have the Lewis structure of the resulting ions, which includes the brackets and the charge of each ion. That fan thing is making lots of noise, isn't it? But that's okay. It's keeping our air clean, apparently. All right, so let's try a couple of these. Here is sodium and chlorine. If you remember, sodium is in group 1, so it has how many valence electrons? 1. Chlorine is in group 17, so it has how many valence electrons? 7. 1, 2, 3, 4, 5, 6, 7. And in order for them both to have full shells, sodium is going to donate one of its electrons to chlorine. Yes? So this electron here moves over here, and now chlorine has a full octet of 8 electrons, and sodium has none. And what we do is when we're done with that, we put brackets around them, and we put the charge on them. Is good? Okay. So Na has no electrons left in its valence shell. We just put the brackets around it and the plus charge on the outside. Chlorine now has a full outer shell. So we show that. We put the brackets around it and we put the -1 charge on the outside. We're not going to get too fussed up about this because AP doesn't spend a lot of time having you draw ionic compounds via the Lewis structures, but so they're not going to get as fussed about not drawing arrows and stuff. This is kind of what I give my grade 11s because otherwise they don't really understand what they're doing. Okay, the regular 11s. Now, if we start with magnesium, magnesium is in group 2, so it has 2 electrons. Yes, and oxygen has 2 empty spaces. Right, because it has 6 valence electrons being in group 16. And so magnesium can easily fill those in. That empties out magnesium's valence shell, and it fills up oxygen's valence shell. Is good? Okay. Now, what if we don't have something that matches nicely? This one, whoa, where'd it go? This one had 2, oxygen needed 2. If we have sodium, which only has 1, but oxygen needs 2, then of course you need to have 2 sodiums. Yes? Does that make sense? So each of them will give an electron, and you'll have 2 sodiums with the brackets and the charge. Is good? Okay. Now, you can write it one of 2 ways. You can either write the 2 sodiums separately, or you can write 2 Na+. Okay. Magnesium and bromide. Bromine only needs 1. Magnesium wants to give away 2, so we need 2 bromines to accept those 2 electrons. Okay, so each bromine gets 1 electron from the magnesium. And now, before we turn to the next page, What's on the next page? Magnesium and nitrogen. We're going to try this one over on the side. If you have a scrap piece of paper or just a little room somewhere, if you want to grab some paper, if you don't have your own, there's some at the back there. We're going to do magnesium and nitrogen. Do you guys think you could do it yourself, or do you want to do it together? I want to do it together. I want to do it myself. Okay, 3 people have voted. The rest of you don't get any vote because you didn't vote. So you're going to try it yourself, and then we will do it together. Okay, we'll take a look. So give it a try yourself. See if you can make that ionic compound between magnesium and nitrogen. And if you get stuck, call me over, okay? Anyone need a piece of paper? Oh yeah, no. You saying you did all of this. So I finished. I finished. We're supposed to finish. Yeah. You did both of those. Not finished. Yeah. Not finished. Oh wait, finished one too. Yeah. You did all the way to that. If you want to check what you've got, it should look something like, whoops, why did I put my brackets on the inside? There we go. There we go. It should look something like that. But like I said, AP doesn't spend a lot of time doing this. I just want to make sure that you have an understanding of how Lewis structures work for ionic compounds, because it can come up here and there. Okay? Do we feel pretty good about that? If you feel like you need any practice, There is practice here, but you don't need to do it. So this is optional. All right. No. The only thing on your quiz is 5.1 and 5.2. Okay, that's it. We're going to be moving on and doing other things because we got stuff to do, but yeah, just 5.1 and 5.2 on the quiz. All right, so we're going to move on to simple covalent compounds, and this is on page 55. And when we have covalent bonding, electrons aren't given and taken. What happens instead? They are shared. What kind of atoms do sharing with other atoms? Nonmetals. Okay, so these are all going to be nonmetals. You can also have, what do you call them? Metalloids. Metalloids can do different things. Sometimes they bond covalently, sometimes they bond ionically. They're kind of off in their own little world. So, but you won't come across them very often. All right, so don't worry about them. Don't be like, oh, I should obsess about metalloids and understanding them because they're not clear-cut. No, don't do that. That's crazy. Okay. So here we are. Here we have a hydrogen atom and a hydrogen atom, and hopefully. Remembering from yesterday, how many makes a complete shell for hydrogen? 2. So basically what's going to happen is these 2 electrons are going to come together and we are going to share it. Yes? So that is one way of drawing an electron dot structure for hydrogen. This also explains why hydrogen is one of the diatomic elements. Okay, and for Thursday's quiz, you actually do need to know your diatomic elements. Okay, now, does anyone need a quick refresher on who the diatomic elements are? Yes, okay. So if you have your vocab list, which is that big, long one, okay, and it looks like this. And if you don't, there are probably some extra copies over in the corner there. The diatomic molecules, there are 7 of them, and there are several ways to remember it. If you know that the halogens are these guys here, the halogens, you can do it kind of like a little cheer. H-O-N, halogen. Okay, that's one way of doing it. So you've got your H, you got your O, your N, and then you got halogen. Yes? So that's one way to remember it. Now, if that doesn't help you, you can ask Dr. Brinkelhoff for a little bit of help. Okay, Dr. Brinkelhoff can remind you. And if you don't like that one, you can also have no fear of ice cold beer. So maybe that one is more to your liking. And the BR and the CL are at the end there. Okay, that helps you determine that they're not carbon and boron. Okay. Now, if you are more of a visual type of learner and you're like, I just want to be able to see it on the periodic table, this is the hockey stick and the puck. Do you see the hockey stick? Do you see the puck? Yes. Now, how many diatomic elements are there? 7. Do you know what element nitrogen is? It is number 7. So if you draw a 7, starting on element number 7, you have the hockey stick and then you just draw the puck. Yeah? So if you're like, where does that hockey stick go? Start on 7, draw a 7, and then add the puck. So that you have a choice of ways to remember the diatomic elements. All right? So if I say to you bromine, and if I don't see bromine atom, you should assume it's bromine Br2. Okay? But if I say helium, is helium one of our diatomics? No, so it's just He. If I say nitrogen, you would think N2, unless I say nitrogen atoms, in which case I mean just plain N. Yes? Okay. And that's why it has to be a diatomic element, because it is not very stable in its atomic state because it has that unpaired electron. Unpaired electrons are unstable. Okay? And you can see here, we're sort of drawing it out for you. Hydrogen A has 2 electrons. Hydrogen B has 2 electrons. Everybody's got a full shell. Everybody is stable. Okay? Now, we can replace those 2 electrons with a line. That line represents 2 electrons. 1 pair of electrons. And when you have 1 pair of electrons that are bonding, that is called a single bond. So up to you. If you're drawing a Lewis structure, you are allowed to draw it either way. Don't draw it with the circles. That's just kind of there to help point out to you. But you can draw it either like this or like with the line. Okay? Fluorine. Can you see how fluorine will form a molecule? How many electrons will fluorine share? 2 electrons. So we would then have, we could draw it this way, fluorine. Or how else could we draw it? We could draw a line. You'll notice that all of the electrons in Lewis structures are in groups of 2. They're all in pairs. Okay, there are a very few, very rare exceptions to this. But in a Lewis structure, all electrons should be in pairs. At least when you've got a molecule. Okay, if you've got an atom, it can be unpaired. But all molecules, all Lewis structures, are you guys okay with MC for molecule? Okay. All Lewis structures of molecules require all electrons to be paired. No single electrons, no single dots. Now, I think probably on the next page we label the types of electrons, so maybe we'll just take a moment and go there and do that. Oh, wrong booklet. That's why I'm not seeing it. Okay, so here we go. We can see this. Da, 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 da. That's just what we did. Yes, here they are labeled. When we have a pair that is part of a bond, we call it a bonding electron pair, or just a bonding pair. When we have a pair of electrons that is not involved in bonding, those are called lone electron pairs. So in this structure, How many bonding pairs do we have? Just one. And how many lone pairs? And if I ever do that and I just put those little dit, it means the word above, right? So you've got how many lone pairs, because I'm lazy and it saves writing, okay? How many lone pairs? Tell your partner in total. It's just to clarify, it's in the entire molecule, not just on one atom. So how many lone pairs? 6. Okay, and that means we have 14 electrons altogether because we have 7 pairs of electrons. Is good? Okay. Do you feel like you need practice drawing Cl2, or can we skip that? Skip? Okay. You can go back and try it if you want to. Same thing works for if you have elements that are different from one another. It doesn't matter. Hydrogen, of course, you have to remember hydrogen needs only 2 electrons, so it's satisfied. But fluorine needs 8 electrons, so it is satisfied. Okay? And you can see, once again, if we look at this, you can say, oh, I look at hydrogen, how many electrons does it have? That line means it has how many? 2. Okay, and fluorine has those 3 lone pairs plus the 1 bonding pair gives it 8. Is good? You guys need to start going like this or going like this. So if I say is good, you go. Okay, lots of goods. Okay. There's some exercises. I'm not going to make you do that. Here we have hydrogen and oxygen. Uh-oh. What's wrong here? Tell your partner, what should you be doing to make this better? What do we need? We need another hydrogen, right? So we need another hydrogen here. We're going to share that. Okay, and that's why water has to be H2O and not just HO. Okay, so there we are. And you could redraw this, of course, as H with a single bond, O, H. Okay, so that would be the other way of drawing it. La, la, la. Now, does it matter where you put them? Could you put them on either side? Yes. Could you put them at the top and the bottom? Yes. Okay. Any of those are fine. And the reason any of those are fine is because this is a 2D representation of a 3-dimensional structure. Okay. So the fact that we've squashed it flat and made it sit in one plane already makes it a little bit like dodgy in terms of its accuracy, in terms of shape. So it doesn't really matter where you put them. Okay. As it turns out, ooh, do I have one? What really the shape really is we have water, we have the oxygen, and then coming off it, we have, you guys know what a tripod looks like? Like that? Yeah? We have 3 things coming off the bottom. Okay, we have a hydrogen. We have another hydrogen sort of coming out the front like this. Okay, and then going backwards, we have another hydrogen. And then coming out the top of the tripod, we have one more. Okay. Oh, not hydrogen. What am I doing? There's only 2 hydrogens. These are lone pairs of electrons here. Sorry. You're like, H3O, what is happening? Okay, so I have a lone pair of electrons there, and I have a lone pair of electrons there. So I essentially have 3 areas where I have electrons. I've got bonding electrons here, bonding electrons here, lone electrons here, and lone electrons here. And this forms a shape called a tetrahedron. Okay? This is a tetrahedral shape.
So you say it's a triangle on all sides.
Yeah, essentially. So let me actually just see if I can find like a nice tetrahedron drawn more professionally than I have done for you. Okay. Okay, so you can see we have sort of three things sticking out the bottom, right? And then the one thing sticking out the top. Yes? And over here, if we were to attach them this way, you can see that we've got, oh, that's not really what I want. That's something else altogether. Isn't it? Yeah, it is. Never mind that one. Ah, here we go. Okay. So yeah, if we look at this one here, once again, this is drawn in 2 dimensions, but it essentially makes like a little pyramid. Yeah? Where you've got like 3 things on a side. Yes? It doesn't matter where they are. So for example, on my crappy little drawing, I could have drawn my H here, my H here, and my lone pair here, and my lone pair here. They're all identical to each other, okay? And this is one of the shapes of a molecule that you are going to be responsible for and that you will be learning later this semester. Okay, so you might as well get an introduction to it now. This shape is called tetrahedral, and it is when you have 4 electron domains. And what is a domain? And a domain is where it's an area where electrons live. And the angle between any of these bonds, they're all the same. Okay, the angle between the bonds are all the same. It is 109.5 degrees. 109.5. Sounds like a radio station, doesn't it? 109.5. You guys even listen to the radio anymore? Some of you. Yeah, okay. Anyway, that is basically the electrons are trying to get as far away from one another as possible. And that is the structure that they make if you've got 4 areas of electron density around the atom. And if that made no sense to you, don't worry. That'll take place in Unit 12 and you'll be like, oh, it all makes sense to me now. Okay, but you had an introduction, you've seen it, so it won't be completely foreign to you. And that's why water is always drawn like this. Yeah, because those are 2 of the things on the tetrahedron. That's why it's not a straight line, because you've got this shape like this. It's a bent shape. Okay? Anyway, interesting things. There's water. But you can see how little that resembles the actual Lewis structure, so that's why it doesn't really matter where you put them in the Lewis structure. There are some practice exercises here. La 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 la. Do you guys want to try NH3? Yeah, try NH3. There we go. So you can check your structure against mine. Did you get the same thing? Good. Okay, question for you. If we were doing, instead of a Lewis structure, if we were actually going to draw the correct shape, how many electron areas do we have? How many electron domains? 1, 2, 3, 4 electron domains. So what shape would those electron domains make? Tetrahedral. Electron domain shape. So it would be like just like the bottom part of the tetrahedron, right? With a lone pair. Yes. Sorry? You would have it in something like there's BH3, boron trihydride. So boron has 3 electrons, 1, 2, 3, and boron actually does not need a complete octet because boron's just a funny little guy, okay? So it actually looks like that, and so you would end up with a triangle, and this is actually known as trigonal planar. Okay, and you can end up with a trigonal planar molecule even without a weird little guy like boron. You can have it if you have a double bond, right? So let's say you have, for example, CO3, 2 minus, and I'm going to show you very quickly, this is how we're going to do Lewis structures when we get to chapter 12. I look at this, and we're not going to learn this now officially, but you can just watch it and go, oh, okay. I have 4 valence electrons. I have 3 times 6 valence electrons. Okay, and that -2 gives me an extra 2 electrons. So my structure is going to have 4 plus 18 plus 2 is 24 electrons. So I have 24 electrons to play with. Yes? Because carbon brings 4 of its valence electrons. Oxygen, each of them bring 6. And I've got 3 of them, so that's 18. And then I've got an extra 2 floating around because it's got a -2 charge. You with me? Kind of. You only have to kind of be with me. You have to just nod and smile at this point. Nod and smile. Ah, yes, Ms. Spence. Okay. So I'm going to put my carbon in the middle because carbon can form how many bonds? 4. So carbon, when you have a choice, you put carbon in the middle. And I'm just going to attach oxygens to it because I know they have to be bonded. Yes? Uh-huh. And so I've used up now 6 of my electrons, right? Because each bond is 2 electrons. Yeah? And then what I do is I go around and I say, okay, well, I'm just going to give everybody 8. Okay? So everybody's going to have 8. Everybody's going to have 2 electrons on each side of it, top, bottom, left, right. And now I count up my electrons. And I say I've got 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26. So that's a problem, yes? So I have 26. So what I do is I erase a pair from my central atom. And I say, no, we can't have you because I'm only allowed to have 24. And I don't erase them from one of the side ones. I erase it from the central atom. And then I grab a lone pair. And this oxygen says, I will be so kind as to share with you carbon because right now carbon only has 2, 4, 6. Wouldn't it be nice if oxygen shared? And like I said, don't worry, this is unit 12, so you can just be like, what happened? I don't know. That was confusing, Ms. Spence. So, And now we can count up our electrons and we can say, I have 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. How many was I working with? 24. How many does each atom have? If I look at oxygen, it has 2, 4, 6, 8. Yes, you got a question? Okay. How many does this oxygen have? 2, 4, 6, 8. How many does this oxygen have? 2, 4. And each of these lines represents 2 electrons. So that's 6, 8. And then carbon has 2, 4, 6, 8. So everybody has 8. We have 24 electrons and life is good. Yes? Because this has a negative charge. So they've come from somewhere. They've grabbed them from some metal atom somewhere.
Where's the metal?
Where's the metal? Oh, because you cannot have carbonate on its own, right? It would exist as maybe Na2CO3. So where did those extra electrons come from? They came from the NAs. But if we're drawing the structure for the ion, we don't necessarily know what metal it's with. Yeah? So somewhere out in the world, there's a metal who gave those extra electrons to the carbonate. Yeah? No, it's okay. You could if you wanted to, but often when we're drawing Lewis structures, we're mainly focusing on the covalent bonds because the ionic bonding is kind of boring. So often it will just be like, draw the Lewis structure of carbonate ion. And then you would do that. And then they might say to you, what is the molecular shape of carbonate? Right? And you would say, well, how many electron domains do I have? How many areas around the carbon do I have with electrons in it? I've got 1, 2, 3 around the carbon. And in order for those electrons to get as far from one another as possible, they form bond angles of how much? 120 degrees, right? 120 plus 120 plus 120 gives you 360, which is a circle. Yes? And you would say, oh, this is that weird name, trigonal planar. Okay? So this has a trigonal planar shape. But like I said, unit 12, we're on unit 5, right? And 1. So just be like, okay, that was fun. That was an experience, right? We'll do this every once in a while so you can see it. And then when we get to it, you'll be like, oh, okay, it's not brand new. All right. Anyway, so usually when you're drawing these things, you do need to identify who is going to be the central atom. If you have carbon, carbon will be the central atom, yes? If you have 2 choices, say you have phosphorus and chloride, phosphorus can form how many bonds? 3, and chloride can only form 1 bond. So that means that phosphorus is going to be in the center, yes? And the chlorine will be around the outside, so they only have to form 1 bond. Usually, in the formula, the central atom is the first one. The first element, which is usually a lone element, like it's a singleton. Like if you tried to put chlorine in the middle, you're going to have a problem because chlorine only has 1 gap in its electron shell, right? So it only wants to share 1 electron with 1 person. It doesn't want to share with two atoms. Does that make sense? Okay, we're going to leave it here for today. We'll come back to this in a little bit because this is not our main thrust. Our main thrust is the Mole. So we're going to go to page 55 in our pink workbook. Page 55 in the pink workbook. Okay, so we are looking here at concentrations of solutions. First of all, what does it mean when we talk about concentration? Like if I had a solution here, and this was my solute. Do you guys remember what a solute is? There's two things, solute and solvent. How many people have heard those words before? Most of you, half of you haven't. Okay, so we're actually going to define these right now. The solute is the stuff that gets dissolved. And the solvent is the stuff that the solute gets dissolved into. And in fact, I am rethinking this. I'm rethinking doing this right now, and I'm thinking maybe we should go back to our fundamentals because there's a little section on solutions in our fundamentals. Let me take a quick look here. Oh yeah, we got a whole bunch of solution vocabulary in our white book on page 65. Let's go there.
The first, like,
I'd like you to read through that first page and tell me if there are any words on there that don't make sense to you. This is page 65 in the white book. Tell me if there's any words on there that are unfamiliar. Give me a wave when you're done reading, okay? Sure, you can take a look at page 66 if you're finished. We're not going to worry about too much past there, though, because then we start getting, oh yeah, well, we do get solute and solvent. Yeah, sure, carry on. So maybe just put a little star by anything that's unfamiliar to you, okay? So yeah, when you finish 65, you can go on to 66 and 67, okay?
My brain, wants to join. I'm not in either. And I'm like, okay, so I have no, and I'm like, yes.
Have you guys ever seen this delta? The lowercase delta? Why don't we practice drawing it a couple times together? Basically, what you do is you start here, and then you go this way, and then you go up this way, and then you go like this, and then you go like that. So what it looks like is like that. So it's like a lowercase d, but a little bit fancy at the top. Yes? Try drawing it a couple times. It's only slightly difficult. Why was that funny? Or why should it have been funny? Because the delta means slightly. Okay? It's not that funny. I understand. But the delta leads us into things like polar molecules. Polar molecules have a positive pole and a negative pole. So what that means is it's not like an ionic compound where the charges are completely separated, like we have a sodium plus ion and a chloride negative ion, and they're actually separate entities, they're just stuck together. We have a molecule with a positive end and a negative end. A very famous example of this is water. Water, we have hydrogen here, oxygen here. Can you guess which end is slightly negative? Think back to your Lewis structure. Yes.
Hydrogen is slightly more positive.
The hydrogen is slightly more positive and the oxygen is slightly more negative. And if you see, the oxygen has these lone pairs on the one end. So that makes our oxygen slightly negative and our hydrogens are slightly positive, which means that the hydrogen end is positive and the oxygen end is negative. Okay? Yes?
So does it have to be a molecule
Some molecules are polar, some molecules are non-polar. So if we had hydrogen and hydrogen, that is non-polar because nobody has sort of a greater electron density. Okay, and don't worry, there's a whole unit where we go through like how to figure out the electron density around each atom and which atoms pull electrons towards themselves. Right now, you just need to know that some of them do pull electrons more, and so they will be slightly negative. Really, all you need to know about right now is water. Okay, you need to know that water is positive on the hydrogen end and negative on the oxygen end. Water is a pure substance. Water is a polar molecule. Look at this. We have all of these little polar molecules. And guess what polar molecules can do to other polar molecules? The negative end of this water is attracted to the positive hydrogen. So there is a force between them, and you can call this an electrostatic force. That's probably what they would call it in physics. But in chemistry, for whatever reason, they love the word coulombic.
Huh?
Coulombic attraction. And I think the reason they like that term is because it has to do with, is anyone familiar with Coulomb's law? Okay, if you're not familiar with Coulomb's law, don't worry about it. It just talks about the attraction between charges. Okay, and we will talk more about that this year, but we have this electrostatic force between positive and negative. We have this Coulombic attraction between positive and negative. And this particular attraction is a force between molecules, and therefore, as chemists, we would call it it is a force between molecules. It is an intermolecular force. Okay? So we have intermolecular forces, which are caused by the Coulombic attraction between positive ends and negative ends of the molecules. So when you have water and you drop some water on the desk, does it completely spread out or does it kind of stay in a puddle? Like, does it just spread out as far as it could possibly spread out, or does it stay in a puddle? Stays in a puddle. And why is that? Chat with your neighbor about that. Why does water stay in a puddle rather than completely spreading out as far as it can? Why does water stay in a puddle? Water is attracted to water. Those intermolecular forces between water molecules hold them together. Okay? And if you get them moving fast enough, like say you were to heat it with a hairdryer, what happens to the little particles if we're heating it with a hairdryer? They're moving, they're jiggling, they're flowing because it's water. And then what do they do eventually? They don't explode. Okay. Here, we have little water molecules.
Separate.
And they start moving faster, and they start moving faster, and they start moving faster, and then they turn into a gas. Yes? Because once you get moving fast enough, there's enough energy to break the intermolecular forces. Yes? Okay. So there we have our water. Because it is a polar molecule with a slightly negative end and a slightly positive end, it sticks to itself via those intermolecular forces. Now, when water boils, we also, within the water molecule, we have a covalent bond holding the hydrogen to the oxygen. Okay, and oh, look, we have it over here. The covalent bond, the covalent bond. So the IMFs, which is short for intermolecular forces, they break when water boils or evaporates. Yes?
But then there's still water.
There's still water molecules, and that's because we are breaking the intermolecular forces, which are between the molecules, but the covalent bonds are really strong, and they would require thousands of degrees to be broken as opposed to the 100 degrees Celsius that it requires for water to boil.
But then can you use electricity?
You can use electricity to separate it, and in which case you're putting in a lot of energy in the form of electricity to do that separating process. Yeah, instead of heat. Yeah. So, what do you guys think of that? So when we boil the water, we have broken the intermolecular force, right? And this water, okay, so we heat it, it jiggles faster. And then it breaks free. And then we have a water gas, but those covalent bonds stay intact because covalent bonds are very strong. Covalent bonds are strong. Do you remember what other kind of bond is strong? Ionic bonds. Do you remember the crystal lattice with little water molecules in and the water flew out, right? Because the intermolecular forces were weak, but the ionic bonds were strong. Okay, so bonds are strong, intermolecular forces are weak. All right. How are we doing? We got a little time. Here we have solute and solvent. The solute is the substance that gets dissolved into the solvent. So for example, if we have salt water, the solute would be the solute. The solvent is the substance into which the solute dissolves. For example, the water. And the solution is the mixture of the two. Over the summer, did you learn the word homogeneous? Yes. What does it mean if we have a homogeneous mixture? Tell your partner, what is a homogeneous mixture? Yes. Yes. Do metals have a gaseous state? In theory, yes. But you would have to get it super hot, and I don't know how hot. Let's see. What is the, well, let's try something like mercury, because mercury is a liquid at room temperature, right? Or gallium, actually. Let's try gallium, because it's really close to being a liquid. Gallium, boiling point. 2,400 degrees Celsius. Okay, so you would have to heat gallium to 2,400 degrees Celsius in order for it to, and the reason I chose gallium is because it is almost a liquid at room temperature. Mercury boils at 357. That's pretty low.
So is it hot thing in the gas form.
So it is toxic in the gas form. And in fact, do you know the Mad Hatter from Alice in Wonderland? Okay, so hatters used to go mad. And it's because they used to use mercury in the making of hats. I don't know how. You could feel free to go and Google that at some point on your own. So they used mercury in the making of hats, and they would have this hot mercury, and they would boil it, and of course they would breathe it. And mercury is a heavy metal, and heavy metals have a tendency to stay in your body. They get into your fat cells and they just stay there, and they do bad things. They do bad things to your neurons because your neurons are coated in fat, right? They have myelin sheaths. I don't know if any of you are taking biology, but neurons are coated in a fatty substance so that the nerve impulse can jump from one node to the next node. It's kind of like an insulator for a wire. Yeah.
So are there any metals found on health?
Probably not, I'm guessing. Because for one thing, if you were to breathe like a gas, it'd probably be really hot. But I can't imagine breathing metals would be good because in your lungs, they would just behave so differently to everything else, right? Because mercury you could breathe, right? If it was boiled. Oh my gosh. Yeah, I don't even know. Yeah.
So if you warm mercury and then evaporates,
Uh-huh.
it's just disperses through the air, so you don't get it. That's right.
I feel like it would settle pretty quickly because it's very heavy in comparison. So even if you have carbon dioxide is heavier than most gases, so it will tend to be like if you get, when you see dry ice, which is carbon dioxide, and it sublimates, it turns directly into gas and it will sink. Like if I had some on the edge of the table, it would the gas would go over the edge of the table and sink down because carbon dioxide is more dense than, say, nitrogen, which is what most of the air is made of. Yeah. Eventually, if it got close to other mercury particles, but it would have to be near them. If there was one over there and one over there, they wouldn't care less about each other. Yeah. Yeah. So we have solute, we have solvent, we have solubility, which is the ability of the solute to dissolve in the solvent. So it's like the solution ability. Is it able to form a solution? So for example, is salt soluble in water? So if you take if you take salt and you put it in water and you stir it around, does it dissolve?
Yes.
Yes. Does salt dissolve in oil?
I don't think so.
It doesn't, but if you haven't tried it, I would encourage you to go home, take a little bit of oil, take a little bit of salt, and stir to your heart's content. Okay? And just stir and stir and stir and see if you can get that salt to dissolve in your oil. It won't work. Okay? Homogeneous mixture. It's where the different particles are distributed evenly. There is a uniform distribution. So basically it means that the particles are mixed at the particle level. You can't see any difference. Like for example, if you have Kool-Aid or any sort of drink, Gatorade, whatever, can you see different areas within the Gatorade? Are you like, ooh, there's a color molecule. Ooh, there's a sugar molecule. Can you see those? No, because they are all distributed so evenly, like they've mixed. It's like you have the biggest blender in the world, and it just it just grinds things as finely as they can. So individual particles are separated from one another. Okay? A heterogeneous mixture is when the particles are not distributed evenly. And then we have AQ. Do you guys know what AQ stands for? It stands for aqueous, and it literally just means dissolved in water. Okay, so here we have some salt in water. And if we just have added that salt crystal, in that instant when we add it in, has it dissolved yet? Has that salt crystal dissolved yet? No. Okay, it's just sitting there. Right now, this is a heterogeneous mixture. We have the water area, and we have the salt area. But once all the salt is dissolved, do you see how all the individual chloride ions and sodium ions have completely separated? Every individual particle is separate from every other individual particle. There's no more clumps of sodium chloride together. Yeah? And that's how we end up with a homogeneous mixture. What time does class end? 46, 44, 44. We got 4 minutes. Okay. Would you like it for your homework to be working on 5.1 and 5.2? Yeah? How are you guys feeling about your quiz on Thursday? Are we thumbs up, thumbs down, thumbs in the middle? If your thumbs are in the middle or your thumbs are down, I would encourage you, after you've looked at stuff tonight, I am here every day during Flex. Come and see me during Flex tomorrow if you want to go over some things. Or if you're like, could you just take a look at this and tell me if I'm going to get full credit for how I'm showing my work, right? Because I can do that for you. So do drop by either during Flex, or if you can't make it during Flex, talk to me and we can make arrangements for some other time. Okay, and I think we're going to leave it there because Block 4 always seems to take more time to finish. I don't know why. It's every year. It's not just these classes. It's just like, they're all the same length, but Block 4, I don't know. Yeah. Yes. So for example, if you had some iodine, some I2, it's a solid, it would dissolve in oil because it is also non-polar. Oil is non-polar. Iodine is non-polar. Those two will dissolve. Yeah. So salt has, and we're going to look at the video tomorrow. It shows like the particles, how they interact. But the salt has like a positive and negative, and water has positive. So the water, the positives would surround the negative chloride, and the negative is associated around the positives.
Let me know next time.
And it's like some salts now and other kinds of
Brian.
yeah. So you know water. Yeah. So like the water solids.
What is, oh, wait. Yeah, that's the thing, it's restaurant.
It's gonna have to be good. Really, yeah. Oh, the only thing is gonna be under molar mass. So like when you have, let's say, you do CL2. So and you're gonna have to like seal it before you get it on. I've never had any CL2 log, if I say yeah.
Oh.
Yeah, okay. I'm not saying chlorine atoms. Oh, okay. Now she's talking. No, like right now. Like, that well, like, you can't have a two hydrates. One is. Oh, yes. Because I had, that was years ago though. That is what to color. Yeah. Oh, I remember, yeah. Yeah, no, this has same height. Yeah. That's so cool. I got all the younger siblings. Yeah. Yeah. Your brother was the most talkative. He's he loves asking questions. Yeah. Like everything. I love when people ask questions though, because it makes it more interesting, right? Yeah. And we can go down rabbit holes because we're gonna go there eventually, right? We're gonna do all the different intellectual forces and how they work eventually. So why not go right now? We guess we're gonna tell us what the shape of both of like 5 to try at the same time. I'm not right now. Wait, so why did you not create? I forgot what you said already. Why did you not create? It'll just occur naturally. Like that. Well, like organically, I'm just using. Yeah. How big are you? So if you dehydrated salt, you just spread water. So if you heat it, so the water molecules then you can switch to water and then they're yeah. And it's set for like 5 minutes. Yeah. Because there's like set structures to coastal where the water spreads. That's okay. I'm not running away. I'm just turning this off. It has salt in liquid form. Does the salt have a liquid form? Yes, you can melt the salt. I can melt the salt. In crucible, in a really high heat, you get this like thing. And in fact, if you want to, I think Niall, what's his name? Niall Red. No, Niall Red. I think the YouTuber, he like melts salt and then he dumps it like on carbon dioxide and stuff. And I usually show that video. I do grade 9. So it's kind of nice to see that, you know, and keep it high enough. Okay, so in the crucible, the ones that we use are made of ceramic. The one that he used, I don't know what it's made of. It's like a bowl that can get really hot. So it would be a substance that melts at a higher temperature again. So why do we melt salt in crucible? We can't like love that. Because your pan will melt before the salt. The melting you need the crucible to be, I mean, you find a pan made of whatever, then you could do it. In fact, people have melted melts in the microwave. Of course, there's salt in the microwave. I don't know if you want to do that, but. What you do on your own time in your own kitchen is your and your parents' responsibility. I hold no sway on that. I just know that we will be doing here. Are we just doing yeah. Well, we're going to be tomorrow we're going to make a solution. And then we're going to make a different kind of solution. Does wood have a liquid solution? Wood is not an element. It's not an element. wood is a bunch of different compounds, and it's got a lot of polymers, which is like molecules strung together in big ones. So like cellulose. Oh, yeah. And I gotta go have lunch. Okay, where is my lunch? My lunch is here. It's
That's right. It's carbon that creates carbon gas that is CO2. But it would be like the rest of the molecules that it would be the rest of the molecules that wood is initially made of, which said like a lot. Sorry? It would be like the rest of the molecules that wood is made of, said a lot. Yeah, and different form. So if some become powder. Yeah, some become like really.
Wait, are you guys all going to the room?
Yeah.
Right.
So like like when you burn wood, it carbon, right? Like it's like the act or like the like probably collapse for it. I know of my passage. Wait, where's coal? Coal is a mineral. You can buy it. Freaking so what's coal in the market? Because it's just by ocean. Why?
Ew. You get start swimming. Huh? Wait, want to go to three? Yeah, I don't want to. I'm just, we want to go to three. No. Well, there's some there. Are you going to see? What? Why? Why? You know, I'm sure. Why the fuck? Relax. No, wasn't sure what. Well, you got lost with that. Well, you got you were saying. Oh. This is I don't know. Bro, why are you like wasting away your last year? This is your one year, so I'm not just like 30. Like, it's usually I'm so it's actually trouble for listening. We're watching the supplies and don't be beautiful to this year once. Okay, I don't know what's maybe this month. Yes. Well, this year once in your year, but we're wasting this year. And this year, it's not last right. I don't know where it's at. Nice. What? Can I get some of that? I'll take. Okay. No, I'll take it now. She doesn't even want it. I'll take it. You don't want it, right? You don't want it, right? You don't want it, right? I'm all thinking. I'm sorry. Why are you taking her? You're a beggar. You'll stop. I have your laptop. This is my match. This is actually like.
Why are you swearing?
Black on black meat.
Why don't you see everyone? You want?
I'm good. Okay, that's wait, and I told can't order $2. I told Emmanuel, look what I won yesterday. What's it? How? I bet it's all this or the what is it? Was that again? 49 is it was 5
I'm kidding. 500 payout.
We did 5
Oh, don't do that. Here's the plan. Welcoming phone to our house at 5:40 a.m. I'm gonna come to my house first. Nothing because I'm scared. And I can't step out. Yeah. You have to get there at 6 or okay, let's pay to leave. We're moving about. Maybe it's just zombies. Okay. Okay, for the way back, you might have to call your sister. Bring us back up.
Why don't you take back?
Yeah, I'm going to school. Well,
Maybe no. Go. Oh, free food. I have. Or then I have. Then he.
This is what I have things out there. Put an eyeball. Okay, I don't know. I think it's crazy. I'm gonna get it.
No, it's because I have now.
And also my sister is no. My sister's not with you. My sister didn't pick me up. I'm actually get ready for school. Yeah. I like to have my friends. Like that's what I'm saying. Go please.
Let me keep that
No, I haven't school. No. You're going to sleep alright? Or next week? I might a whole next week.
Why? Right. You know, won't go.
I would need 2 weeks off.
Minimum 1 week, right? Crazy.
I'll take 1 month. No, pretty crazy. Well, I go to Luton Tuesday.
God damn it.
I never. I keep that guy. Yeah, I since I learned.
Wait, you have,
Yeah, I can find me out.
wait, when you lost the area, you guys are,
It's stupid.
you know, I didn't write so much.
Oh, you got it.
I don't even know what happens if you can go about different ways. I'm gonna.
I could go.
Yo, you want snow?
Well, we gotta drive.
Oh.
Red.
Literally. Where's my air go?
You'll probably got you right now.
You need to go Thursday.
Be ready. 5 a.m. Ready time. 5 a.m.
No, I think we talked to them like y'all. They not like us.
Oh, you were not your business.
They not like us.
The sales are parking, you want 70 to 83. I'll see. Okay, that's what I.
First, my bro.
So every time we drive for Sunday, we're doing. I slow down.
Yo. Anyone got 250? I'll look, yo. I'll give this for 250.
Like
Not for you.
$2 cents.
Yo, man, why you laughing?
Early on. It's good though. Like, right.
No.
It's their algorithm.
Yeah.
But after you get 2 bucks. You're paying. You're broke at 4,000. I see my money, right? I have more money than people. I don't know. How much you have?
Then you go to
I pay taxes, right?
Alright. Okay. But like, you have to get our house at like 4, 5, 4. Okay, bye. Remember the day.
A lot of time to do it there.
What?
We're on it. What? We're on it today.
Are you getting here?
I already moved on.
No, we were so close. What? I mean, lots of stuff. Good. Yeah.
Go. That's what I said. No, I meant just today. Just today.
And then iPhone, then I got how many days?
I'm on Thursday though. I'm on Thursday. And then you go stay out.
I'm just gonna be good.
Yeah,
Well, there's one for
no make no
full
mistake.
week.
No make no mistake. I'm on Thursday. You game.
I go sleep.
My mom's driving home, right? Yes.
Sure. Be sure.
Yes, I'm sorry.
Honestly, dropping off the.
Like, I call it.
Oh, what do you say? No, are you drinking?
Watching.
No.
Not good, I got to go.
You get hungry, you go.
And you get,
I just have to we'll take it to the
I don't think you guys have concert.
Oh, what?
You guys have a concert?
Great.
Oh, yeah.
And we, I'm gonna
They
have,
never come to
I'm gonna have, credit.
Do you know, can you guys sing a song? How much are the tickets?
There might be like a. There might be a discount.
there might be this couple.
I'm gonna do a discount, I don't think a lot of people are going to.
Okay. Yo, man, why are you laughing? Look up. Look up. Look up. I'll talk to you later.
Why are you acting different?
Wait, where's the only?
Oh,
You know.
You want to? Are you not on the car? Where are you being featured on the song?
No, basically. For it's probably right? So we already said that one minute.
We're both ready.
Why are you guys doing it with the
No, it's from home.
person?
No, not.
What? Who's the UBC guy?
No, that guy already, right?
Well, he just came to show us something.
Who's AZ?
Brown boy.
He played with this also in the sky.
Every time
I was looking up his friend for that. And he was in the middle of the circuit with
Yeah, I see a brown boy.
Yeah. So much.
AZ?
Sure.
He's on. What's on?
He's actually this guy.
Brown boy on this.
Yeah, but what is his name?
What's Ela? Brown. Oh, he's
Jake. He's like the whole way to reach it out and something. Right? We need to collaborate with one.
Oh my god, are you gonna be SoundCloud artists after that?
Oh.
We'll probably come with stories. It's not.
No. Right? We need to collaborate with we can want from outside of the
Oh, we don't get it.
Like, there's people that are
Sounds like everything.
So, you know what I'm gonna do? This is my idea.
So,
Right?
okay, that's not what's in front.
My idea right now is to Sean out of the event. I'm just gonna send him the rest of the
Go straight.
lyrics. Let's send him the lyrics.
Why don't you a band like drummer, bass, guitar? I don't know.
Wait, hold yeah.
I don't know.
Stop! You're like, you just be so cute in a band. You just need to be a whole guitar. You need to see it.
I don't know about that.
My best friend is like a little song. That way.
My last.
Go look at all. Like, everything, like,
What was
he's
it?
a nice guy, right?
Alex, you remember? You know, he's just like, yo, this is soft. Maybe you want like so we
You're not saying that. If I do that, that's weird.
Brown.
She was there.
If I go, get
Remember almost speaking? Yeah.
see, I'm sitting in the hour and honestly yours. I think AZ, yeah. What's your little band name called? Black and white?
Yo, don't why are you laughing? Look up. Look up. What's up, Mike?
Yeah, when you get that, when you get the traditional area of Langyara in the city, you gotta say, I know what that.
That's what you're gonna be looking at with having been
It was an 8-hour exam to go.
Oh, yeah.
8-hour exam.
I'm doing special entrance.
Special entrance? On D, you're gonna be a special entrance. And we're gonna be ready.
I thought you did. I thought I did. But again,
So you remember bio when first?
we were you born here?
I was born here.
You're fall asleep during the day.
Sorry. You're supposed to be a round character. Yeah.
So are you actually gonna write it down? There are 8 hours for this shit that
What? Like what?
No, that's just almost my first shift at Airport.
Why am I living? What is?
Well, I remember I got fired the first day.
And laughing.
Well, I got fired halfway through the first day. Halfway through.
No. You don't have to be fired with someone. I came late and I had 2 hours of sleep. And I sat down to write the test. I was sleeping.
That was 2 hours.
And then you know, this guy was claiming 14 off this. That's like 30%. Next time he got 40, bro. 40%. I'm laughing. We both failed, bro.
Got smooth brain, bro.
You're about to switch to career, bro. Didn't you fail to pick up twice, bro? I don't know why you took change.
No, I got just
Yeah. Wait, what's the testing about?
This one's called the persuasion. Really, you know what? Do you see the photo that's in the AI generated? See the AI? You know what I sent it from? I was laughing when I was sitting.
Bro, can you
Okay, well,
Yeah,
you lost school?
No, it's
Wait,
just
study the bar exam. Wait, actually, yeah, exactly.
Wait, you know this one? You know what's his name, bro? The Renegade? No, what's his name, bro? The button TikTok.
Are you? Yeah. Are you?
I'm sort of white out, so not all three of you can match.
Oh! Give me a repeat your whiteout.
And you know what they said? They said the fun. Soon. That's what they said that was like.
I love
This? Yeah, it's the same. I have like 3 white up in my bag.
Maybe it's like
What?
Is that upper?
Personal desires, I don't know.
what's an unboxing? Oh wait, you're gonna take them.
No, I don't know. What?
The unboxing guys.
Bro,
Not the-
how do you know this? On purpose.
Yeah, why do you know that it's actually the same?
Yeah,
I'm
she
just
was watching it.
explaining.
I
Did
like
you say
so much whiteout now. I have one like I lost him now.
How's that plugging in? That's what I'm saying.
Right, pointing here.
Well, this is
How is that plugging anything?
like there you go.
Where's the fun center?
You're on video.
I didn't even look at Dylan when I figured it out. Because
This is funny, bro.
You always said why that?
Dylan, why are you laughing?
You look at them, right? When you say a joke, right? When you say like, oh, we're on 30 truck, everyone will think this face, right?
Nice, I love it.
So I have to keep going.
I'll blow my shit up.
Right here. I'll take my dad with me though. Where?
Oh.
You feel one in the car, probably with the yellow wheel.
No, okay, the thing is, it opens all day. I could do a mean fried steak, bro.
Okay, that's me and him.
Do you know how many cars?
You're gonna hitch a ride?
Because after the last time, he never moved. But this is the reason.
Okay, so I put out.
That's why I wanted to know.
Because we never wants to study.
Where should I study?
Miss school. Please.
So you just tell them that it's easy.
Bro, school's not real.
The unit's easy.
What's the serious one then? 7? 8.
It's zero, sure.
Not 8, it's just at 6:30.
Hour.
The sunrise is not gonna be like an hour long.
An hour.
The sunrise is
We already
long.
tested it for 5 minutes and it was somewhere. Oh,
Well, we
no.
need to tell us
What to do?
I don't
Play soccer?
No, there's people that want to sort of say.
women. Women just pull one.
Oh, you know that one guy,
Oh,
that guy. You know,
Alan?
Huh?
That guy, Alan?
That guy.
Oh, Brad. Oh.
I think it's a five guy.
remember, you know, he's the city big drinks and shop. You do that now. What are they pre-gaming for? Was pre-gaming school?
I don't know.
Are you?
Pre-gaming to watch the sunset.
Are you and you saying for the same thing on the
Yeah.
What is that?
Oh, got it. We have to have some.
But watching good and
The people like this.
What?
What is this?
We're gonna see fucking rock though. Rock on our world.
What the fuck?
Remember last time we went to Denny's and he was serving our table?
Oh, my brother told me this boy. I don't know about that, but let me get this straight. Because it was semi sunrise, right?
Yo,
And then he's like talking for 30 minutes. Like,
Not a question to ask you, this is a question.
I have some good stuff.
Why the fuck you make that?
who said that shit?
I follow it.
You're the originator, no?
Those seem like
Oh, that's like really neat.
really cute little picture.
They look like a sky stuff.
You don't know.
Remember when you got fired as guys?
I'm not like you think you're fired, dude.
Yo, so why are you looking down for
You're not you got fired, too. You're actually not.
Shut it up. Go from my last one.
Yeah, combine last.
Bro, that one shit for my last shit was the worst shit of my life. I woke up the next afternoon. I still had it just though. After that, the worst shit, bro.
You only had some shit in my life.
Well, they're not. No, why are you laughing?
He said, he's supposed to have your problems with that.
I think it's funny, guy.
No, he did not say that. Oh shit!
I swear I said it was funny. I didn't say, okay, maybe I didn't say funny, but I just,
Swear on your life.
all my life, I didn't
Do we end this? No, who said I was fucked up? Good. Excuse me. I'm big. Why didn't you read that?
No. How about job doing it and not wait at school, right?
I'm not the one driving.
Sure.
The bar or bar?
You bar.
I'll bar.
Wait, my mic told
Last time I heard you driving, I was still on the road.
No, that was the first time I ever drove on roads with 3 lanes.
Yeah, so if it was the first time you ever, how many times have you driven? 3 times. She wouldn't have let someone drive the car that's only driven 10 times.
I can drive. I go a lot.
Imagine, you look at him.
Anyway, that's funny. Or maybe they dropped us off at Denny's, right?
How many people get?
They dropped us off at Denny's. All of us.
Are you gonna shove everyone here in her car?
He's supposed
Near Maria's car.
We were actually big public. She didn't say no.
So funny, that's really cool.
So what did I do?
What did I do to?
What did I
Oh,
do?
because I didn't see us. We were dropping off at work, right? Then they were with us. And we told him specifically we're gonna go to Edmond. When we were in the car, he was beating him up in the back.
Bro, are you fucking stupid?
We
I agree. No. I
highest volume, ignoring him.
Yeah, but you don't listen, you don't
The highway.
You
Walked back, walked out.
Well,
And
every
it's
year,
fine
I
for you were there.
I
wanted
really
to
said
straight.
like,
I was just like, not.
I feel like
just
this.
like.
Right.
right, nice.
I'm sorry,
You want to go here. Sorry, you're right.
And then we were about to decide like this, I would actually.
I was just asking
like my whole house
stop
stops
here.
You
Instead of
want
like,
like, that's not fun. Right, you
right.
right. Instead, it was like this. Well, you could have just taken my selection. Why are you scared?
Yes.
Why are you scared?
Y'all said yes to this.
No, we did
But then-
not.
yes, you did. Anyway, and then when we get in the car, instead of going like this, she starts going like this.
So you rather be.
And this guy, no, before we got on the car, I clearly said, and I need to jump out of the right side. First, and I got on the right side, and he's walking around the car for no reason. So now all these
No,
other,
because you time in the library, we said, stop. Yeah.
obviously I'm gonna pull it fast out of my side of the car, so I'm gonna go over it.
I didn't think I should.
Obviously.
Yeah, more, right?
Then why are you
Oh,
laughing?
I'm like,
Why are you laughing? I'm amazing to me, bro.
I'm doing that every time. You see that?
Maybe it's just.
That. Either you see that again,
No, I don't even know what I did.
He throws the rock.
Yeah.
It comes out this week, so y'all just like, oh my God. Yeah, it's just being the
Charging up. See what happened in the school?
Yo, we interested. Yo, I got
I got
some. I got some. Go ahead. Tomorrow I can get it. Once you put it chips.
But you just like,
No, that's what
Wait,
we
yeah.
she was like, yeah.
I don't think she'll be able to. That's probably the last time I can. Okay, I mean, take that one.
Alright, Aiden, like what are your interests this year? Like
Go ahead.
what minimal rights?
Now, why are you asking? Why are you asking?
What about,
She says restriction on freedom of speech.
Okay.
I can express himself. What's wrong? Alright, so you're interested in like home or working on.
If you say Peter Piper, I'm gonna get a five.
it's not that we can never have to
Wait, what?
I think,
What did you gonna say?
I think.
She said that somebody that is not in charge of the movement.
I think men should be really
What?
Like no woman wanted so. No, because when he was thinking about elevators, when he saw me friend, and then he looked at each other and smiling.
You say a lot of guys.
No, girl.
What the fuck you want me to do? You okay, hold on. This is the first time there's. Oh my god, you're so beautiful. What's your name? What the fuck are you talking?
You know how you spoken her, how do you like already like all the way.
Hey, the joke. Obviously, I was looking at it. No, dragging it out. Oh, I didn't say anything. I didn't say anything.
We're in the studio, right? Let's
I was thinking, but you can't make any music, right?
No,
What the
no,
fuck
no.
are you talking
Look, this is the computer, right? And I'm sitting right
Oh,
here.
you were there.
He's standing right here, and there's a girl that walks in. This is it. Now rocking the window. So listen, she walks in. She walks in.
What is it using you? I did not. What is it using you? I did not do.
No, listen. No. This is like the back. This is the back, right?
And you.
This is the back. I'm sitting right here. I'm sitting right here.
That's funny.
Then she walks in the back door. Then she picks something up, right? Obviously, I did. But you did.
So it looked like your best.
What?
I know, but just I can't look at it. First thing you do. Bro, I'm gonna give you a green right there, bro.
Who are you?
You know how you do the very back.
They're like veggie.
Yeah, okay, you guys are saying what's it.
Potatoes and meat.
Did you put it on God that I'm.
I can't do that. We can do that. You did that. You overlook me. I'm literally doing like this.
I just always look like that.
You take the name off. Okay, David. You know down.
That's what it said.
You know what you say this?
That's I was saying yeah.
Huh? So you weren't. That's not how you get to Aiden. You gave it to me. And my continue this pretty story. I was like, that's the best.
It's actually that's what it is.
So while they're walking, she's like, yo, they're getting to Aiden right now. That's what she said to me.
Wait, car.
Your strength is you don't discuss folks. You laugh at me once.
If I put every single line of video that actually came, why did you
say
you change the light bulb? You couldn't change the light bulb.
Yo, I'm gonna say this. You need to change your whole reputation.
Ooh, you think that?
It's taking a lot of things.
I don't even know
What?
what I don't even know.
Bro, why is it making you laugh?
Bro, he's gonna walk in and say things.
He's actually taking on this.
That was so fake.
It's very mad.
Nothing.
You don't feel back. You don't feel
Wait, hold on.
Yo,
You actually.
you should go and talk and say, oh, sorry.
No.
Can I please have a first aid? After the office.
You don't see
Well, that's not my
You know that
mistake.
you
That's
go.
not my mistake.
You go.
You
This guy says really great shit on me.
Don't go for mistake, whatever, you want to play up with the people.
Well, last time I had to change someone that had it in this.
Wait, what?
Or like contrast, you know?
Oh, it's not. Yeah. I like the elevator. Oh, yeah.
Oh, you put that over, you use the elevator.
Alright.
No one actually does it like that.
This is actually really good.
Obviously, you ask why do they try to find them? Watch the same thing.
It's not like. Yeah, but why?
Oh, I don't know why. I'm sure I said why do they try to watch it? Like it's fish destroying. Why did that have a drop? Why did I have a drop? Why did that have a drop? No, they were destroying the house. They were hacking.
Yeah, but why would it destroy your house? Like, I get it.
That was just like
No, it wasn't.
why would I have one?
I know why you're talking about.
No, last time you wrote down the neighbors.
And then.
Loud, and loud.
I can't see anything.
Ms. Dare, please come to the office. Ms. Dare, please come to the office.
Yesterday, you're not last week, right? I walked through my signal with them. I was looking for that stuff.
I also read this and said it's for okay, right here.
Are y'all gonna be just for problems?
Because I hate my.
I'm gonna be like, oh, yeah, I asked so, I sit right for the guard on this. These guys. Alright. Are you guys be just on? Okay. No problem. Are you guys just problems?
I haven't got that far yet. I don't know.
What
What are you gonna be?
Oh, it is. Actually,
Close
actually, go back. Weekend is weekend.
No, I was watching it. I had to make it. No, I'm not doing that. And you gotta. Oh, we're gonna look at this.
What are you
Lizzie.
That's good.
Yeah, exactly. What's it about?
That's you.
And
That's friend. I watched it.
wait, so you only met Lizzie that one time? You only met Lizzie that one time? I don't know.
They made a whole story. They made a
Oh,
whole like.
that's what she was. She was like, she's so loud. All like black.
They were.
Wait, actually, me a white boy, right?
Yeah.
She needed a white boy, but you were not there to provide, and you both got that.
And he's so cute. But apparently he got this guy. I see red.
Oh my God, it's a pretty run.
A little black man grab their guy. Then call this black.
I mean, oh.
Oh my gosh.
I'll go with
They is out.
I think
I didn't say here.
Yeah, we did the very long.
You don't know what it is.
What?
Oh!
I need classes. I can sit beside you. Give my words. That I can start my thing.
Oh yeah, good. And like you said, I did like. No, it's like it's like I was. It's so scary. You drive. What is so annoying? Every time he
Don't be fools. Yes. You have to talk this time.
I heard and give your thing or yeah, so
Oh, and I just have to figure out where we have seats. Do you guys know where we have a blank seat? Right there. Right here. Okay, cool. So we have a blank seat right there. Walk. There's like one over there somewhere also, but this one.
yeah.
Here's after a while. Cool. Okay, I'll get you the. Whatever else. Okay. So this is. Makes sense being hot, but it's just starting to.
Whoa.
Nobody else would get. Right, here we go. I don't read that.
Yeah.